Betelgeuse, or the Metal G, is a red colossus. Betelgeuse would extend beyond Jupiter's orbit if placed where the Sun is. It is massive, extremely unstable, and about to burst. Prepare for a grandiose calamity of never-before-seen scale. Betelgeuse, a red giant star at the edge of our galaxy, is sending out terrifying signals into space. This massive object contains a troubling finding for astronomers. A very serious warning has been issued by renowned scientist Brian Cox using the James Webb Space Telescope. The constant inquiry is, are we about to witness an explosion of a supernova that will forever alter the night sky? Let's get right into it. The birth, life, and death of stars in the vastness of the universe are amazing. As of late, one star has grabbed the eye and worry of the two space experts and the overall population. Betelgeuse, a red supergiant star in the heavenly body Orion. It is extremely ancient and massive. Despite the fact that recent events have heightened interest in this cosmic giant, its distinctive reddish color and varying brightness have long been intriguing. A potentially significant event in Betelgeuse's history is on the horizon as we learn more about it. But what might these Betelgeuse changes mean? Is this the beginning of a cosmic spectacle of unimaginable proportions? Betelgeuse is a stellar giant that is approximately 764 times larger than the Sun on our planet. It is almost too big for us to comprehend. Imagine a massive star whose surface would cover Mercury, Venus, Earth, and Mars if it succeeded in replacing our Sun. This titanic size shows the actual glory of Betelgeuse as well as demonstrates its stage in the heavenly life cycle. As a red supergiant, Betelgeuse is approaching a mind-blowing finish, growing and cooling in the wake of depleting the hydrogen in its center and combining helium. What about the age of Betelgeuse? This star is assessed to be somewhere in the range of 8 and 8.5 million years of age. While moderately youthful in human terms, it is antiquated in heavenly terms. Betelgeuse has changed dramatically over millions of years, evolving from a hot blue star to the red giant we see today. It is currently at the end of its life as a red supergiant. The ongoing pressures of nuclear fusion and gravity cause stars like Betelgeuse to change throughout their lives. This stage of Betelgeuse also stands out because of its distinctive reddish color. Its surface temperature is lower than that of other stars like our Sun, which is why it is red. Betelgeuse's surface is approximately 3,500 Kelvin, while the Sun's surface is approximately 5,500 Kelvin. This cooler temperature permits Betelgeuse to transmit light at frequencies that cause it to seem red. However, this color reveals more about the star's physical state and the processes that take place within its vast gaseous volume than just its appearance. Betelgeuse's mystery is heightened by the color change over time. Betelgeuse was yellow around 2,000 years ago, according to Roman and Chinese historical records. Arabic astronomers noticed that it was red by the 9th century. The evolution of the star can be seen in this shift over human history. Betelgeuse's changing brightness is another intriguing feature. It is a semi-regular variable star, which means that its brightness changes on a regular basis. For centuries, scientists and astronomers have been captivated by this rhythmic dimming and brightening. Betelgeuse typically has a 400-day cycle and a longer, 5-year cycle. These cycles were first recorded by Sir John Herschel in 1836, and Aboriginal folklore may go back even further. Be that as it may, what genuinely makes Betelgeuse strange isn't simply its brilliance changes yet their abnormality. Betelgeuse, in contrast to many other stars, occasionally deviates from this pattern, pointing to more complicated and less well-understood processes within its immense form. Betelgeuse's appearance has changed dramatically and unexpectedly, shocking astronomers and stargazers worldwide. Numerous questions and concerns have been raised by this unprecedented dimming. The current name for this is the Great Dimming. The red supergiant Betelgeuse, one of the brightest stars in the sky and a prominent part of the Orion constellation, began to mysteriously dim toward the end of 2019. The star began to lose light at a rate of 0.01 magnitudes per day on average as a result of its rapid dimming. It was much fainter by February 2020. Betelgeuse, which is usually visible to the naked eye even in areas with a lot of light pollution, became much less visible, and even non-specialists could tell the difference. Because light takes so long to reach us, the time paradox makes monitoring Betelgeuse's activities more difficult. When we look at a star like Betelgeuse, we are seeing it as it was in the past rather than the present. For Betelgeuse, the light we see today left the star very nearly quite a while back, for what it's worth around 725 light-years away. It is difficult to predict and track its rapid behavior changes because of this time lag. The Betelgeuse dimming incident brought to light the difficulties of observing the sky in real time, as well as our inadequate comprehension of the vast and enigmatic realms of space and time that they inhabit. As part of a 3-year study to track changes in Betelgeuse's outer atmosphere, Andrea Dupree, deputy director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored Betelgeuse's celestial drama. The massive star was observed by them through the Hubble Space Telescope. These perceptions gave new experiences into how a variable star like Betelgeuse works. Changes in brightness are caused by the regular expansion and contraction of variable stars. Due to Hubble's sensitivity to ultraviolet light, researchers were able to examine the layers above Betelgeuse's surface, which were partially heated by the star's swirling convection cells. The movement speeds in Betelgeuse's upper atmosphere were discovered through further examination of Hubble spectra taken at various times in 2019 and 2020. Magnesium Roman II lines made up the majority of the spectra, indicating the star's atmospheric conditions. The investigations showed that material was moving from Betelgeuse's surface into its air at around 200,000 miles per hour. The dust cloud that dimmed Betelgeuse's star for 3 months following the outburst was eventually formed by this hot, dense material as it traveled millions of miles away from Betelgeuse. According to Dupree and her team, approximately twice as much material was ejected from Betelgeuse's southern hemisphere as usual. Betelgeuse's mass loss was particularly notable because it occurred much faster than that of the Sun, despite the fact that all stars lose mass over time. Given the magnitude of the mass release and the subsequent dimming, astronomers debated whether this event could indicate an imminent supernova explosion. Betelgeuse's location, which is approximately 725 light-years from Earth, adds to the mystery because any such explosion would be visible from Earth and provide a unique opportunity to observe a supernova from a close distance. However, the issue remains: what implications does this dimming have for Betelgeuse's future? Is it an indication of an impending cosmic explosion, or is it just a one-time occasion in the star's long and complex life? This rapid change has been the subject of numerous theories. Due to the belief that Betelgeuse is nearing the end of its life, one popular theory suggested that it was a stage in the process of a supernova explosion. Our view was being blocked by dust, possibly from the star itself, according to another common theory. Betelgeuse and other red supergiants are known to shed material, which could build up into a dust cloud that is thick enough to block the star's light. A third theory looked into how changes in the visible outer layer of the star, the photosphere, might affect the star's apparent brightness. A combination of observational methods and in-depth analysis was used to solve this puzzle. Betelgeuse may be dimming as a result of a large dark spot on its surface, as evidenced by spectroscopic studies showing a drop in the star's effective temperature. This idea was supported by the fact that Betelgeuse's temperature dropped by at least 170 Kelvin during the dimming. This demonstrated tremendous changes on the star's surface. The Hubble Space Telescope, which serves as humankind's space watchdog, ultimately assisted us in comprehending this unusual event. Hubble's perceptions showed that the darkening of Betelgeuse was reasonable because of a lot of hot matter being launched out into space. The amount of light reaching Earth was diminished as a result of this material forming a dust cloud that obscured a portion of the star's surface. A large convection cell on the star's surface was thought to have produced the extremely hot plasma that was thought to have formed the dust cloud. As this plasma traveled through Betelgeuse's hot air to cooler external layers, it shaped dust grains that made a cloud obstructing light from about a fourth of the star's surface. The ultraviolet light spectroscopic studies conducted by Hubble, which began in January 2019, played a crucial role in determining the circumstances surrounding Betelgeuse's dimming. In the months leading up to the dimming, these studies found that hot, dense matter was moving through the star's atmosphere. The star's brightness decreased in December 2019 by several ground-based telescopes, particularly in its southern half. The ejected material was initially brighter than the star itself, but as it cooled and moved outward, it became a dark cloud. The star's sudden dimming was thought to be caused by this outflowing matter and its dark cloud. This blast was tremendous, putting Betelgeuse at the focal point of cosmic consideration. About 400 billion times more mass than is typically released in a typical coronal mass ejection was released by the star. Betelgeuse and our comprehension of stellar processes were significantly influenced by this material, estimated to be several times the mass of the Moon.